Watch carefully. 5, 4, 3.
You didn't say 2 or 1.
Oh, you don't say 2 or 1.
Why not?
You just don't. Okay? Now, it goes 5, 4, 3. Good. Okay. Good.
Hey everybody, it's Paul Thayer here with another vlog on video game development for my Kokoban, whatever you want to say. I have no preference and don't care either way, and nor do I know how it's supposed to be pronounced. So I had already recorded this once and realized after, I don't know, however long it was, I was on mute the whole time. So that would have been a really interesting video. So last time we were talking about this, I had used the A-star pathfinding algorithm for my beholder, which is the little dude, the blue dude with the eyeball down here, to find his path, the best path to the character or the player, and move that way. I kind of thought it was a little bit too intense, so I modified it and removed the A-star pathfinding algorithm, which first of all was eating up a huge amount of cycles. I've now reduced that cycle count to a substantial amount lower. And we're using kind of sort of the Pythagorean theorem to figure out where to move. Basically, what happens is each time the player moves, the beholder is going to calculate whether he's above or below. He's going to calculate if the player is above or below, or the player is left or right, by measuring the distance away. And then he's going to take that determination and he's going to measure the distance, and whichever one is the longest distance away, he's going to move in that direction. If he can. If he can't, he just sits there. So, not quite as smart as the beholder we knew last time, who moved no matter what unless he was completely trapped or surrounded. Now he moves, but he's kind of only one step ahead. He's like, nothing's in my way. I can move here. I'll go here. He's closer this way. I like the results. I still have some more tweaking to do. I've found a couple of things in testing. One I know for sure. So right now, the beholder looks at a tile table, which I'm going to explain here in a second when we get into the code, which is basically a table of the walls that you see on the 10 by 10 grid there. So all of that orange stuff. Also the key and the gem and the lock is on there. Those all count as solid tiles. So he looks at that and he sees solid tiles and determines his move on that. So basically, where he's at right now, the only option he would have is up. Also, he looks at an object table, and every object on there, whether it's pushable to the player or not, he views that as a solid object that he can't move through either. Now, with that, I didn't build in any code to where when he sees the player's object in that table, he goes to that square. Right now, he just sees it as another object or an obstacle. So he jumps away from you instead. And you'll see some of that behavior here in a second when I do a demo of that. So you'll see he's a little bit dumbed down from last time, but he's still pretty much on it, which is what I want. This particular puzzle is just kind of dumb. It's not designed in any way for you to be able to trap the beholder. I'm not saying it's not possible. I'm just saying that it's not designed to work that way. So I'm going to push this gem down right here as soon as I go over to my VCC window. Push that gem down, and as you see, he moved up because there was a wall to his left, a gem below him, and a gem to the right. And in that code, he determined that the player was above and to the right. And the longest distance of those two was moving up. So now I'm going to move to the left. He's going to move up again. I'm going to grab this key, by going down, and I haven't programmed in grabbing the key yet. And he moved up. And so now I'm going to go up and I'm going to run towards the exit because as if this lock right here had been removed and I could go to that green gem. One false move and I would have, you know, the beholder would have killed me. So as I said, I haven't programmed any of the collision between him and the main character. So when I press up, I don't move anywhere. But as you can see, he follows me around pretty well. There's a couple of instances here where I can get him to, I don't know if it's going to work right now, but he kind of doesn't move where I want him to because he detects the player as an object. I might have to restart this. I'm going to do that real quick. It's only going to take a second. This is the thing I love about using Notepad++. I can hit F6 and enter, compiling my code down there in the bottom, boom, up in VCC in a matter of seconds. So how did I do this last time? And as you can see, he kind of sits there where he doesn't have like a real nice path because he's not looking over all of the board. He's just looking at what's in front of him right now. He knows where I'm at, but if it's not worth his move, he's not going to. So, yep. Instead of moving to the right, he moved left because he was above, or wait. Instead of moving left, he moved to the right because he was above and right. And right now the algorithm looks at, okay, the player's above or below. In this case, it's above, so I'm going to see if I can move up, left, or right. And since he was to the right, it just looked at moving up or right. Or I got that wrong. I'm sorry. That was brain fart on my end. Anyways, he moved in a bad direction, kind of. He moved away from you instead of towards you. And that will happen. Nope, it didn't happen there either. Dang it. I know that once I came in here, he viewed me as one of the gems and moved away from me instead of towards me. Basically the same behavior you just saw a second ago. See if I can recreate it again. So there's a couple of things that need to be tweaked here, but I'm getting a lot closer to what I think I want to have. Let's see if that. Nope, it didn't matter. He was like, yeah, you're right there. I don't care. uh, there was a specific instance of this, and I can't think of where it was. I'm pretty sure it was when I was down here. That's not doing it. Yeah, one more here, and then we'll get into some code and showing you how it works, and maybe getting into a little bit of how assembly works for those of you who don't program in it. Yeah, that didn't work either. And as you can see, so I have a little red border there. Sometimes it's yellow, depending on if I have the composite color set or if I have the RGB. In this instance, we're using RGB. That's measuring the total amount of time that it takes to process everything every frame. So with everything standing still, processing those 1, 2, 3, 4, 5, 6 gems, the beholder and the main character. So that's drawing everything and refreshing screens behind it. It's taking as much time as that red stick at the top. So when I press a movement key, you see how it flashes a little bit lower? It's taking that much more time to process which way the beholder should be moving. Now, on the other, with the A-star pathfinding algorithm, if you watch that video, it was about anywhere from about 4 to 20 times larger than that. So I'm happy with the cycle time results because I'm trying to get this all inside of one frame and have about 25 objects be my limit. And so that means that, can you see my arrow? Yeah, basically you can see my arrow. I have until just above where my arrow is right now to make sure everything happens. Otherwise, there might be some tearing in the game board here because if the processing takes too long and the roster gets down to here, it might tear above. So anyway, you can see how he's currently moving now. So let's look at some of the code that drives that behavior. So I have an assembly routine here the file name is advancedbeholder.asm, and I just include that into my main program. And it's a function that we jump to. So beholder pursuit function is the name of this. I'm just learning all this dynamic assembly coding, so some of my labels might be a little long, and I don't know. Anyway, first thing that we do is we load the A register with a character move flag from the object data structure for the beholder. So let me explain that a little bit more in depth here. So Y, register Y, is pointing to the data structure for the beholder. So object data.asm right here. This is the data structure for the beholder. This is what loads in from the disk whenever a level is loaded in. There will be an object, there'll be a certain amount of object data that comes along with that level for everything that's in there. Gems, laser emitters, the main player, the beholder if he's there, a couple other characters that I have planned. Anyway, that data structure gets loaded in, and it tells you a lot of different things about that object. So the first one is if it's active, the starting screen position. So whenever we have to restart, we want to move back there. The frame ID, which is used in the main player, it controls the frame rate and everything else in which frames it shows. And then there's a direction variable. And in this case, for the beholder, I've made the direction variable, which is an offset of 0, 1, 2, 3, 4, 5 into that data structure. I have made that the character move flag. So whenever the character moves, that particular spot in memory gets changed from a 0 to a 1. And then once everything gets processed, it resets back to 0. So it only flags if we move. And I have an equals file, and this is for the assembler to know where the equals, what those different labels mean. Why did it not load it? Did I not click on it correctly? Is it already open? Well, this is one that's outdated. But just to show you, so active flag is an offset of 0 into the object data table. So active flag, right? It's at byte position 0 into that data table. We'll go back to equals. Starting position is at byte number 1 in that object data. So right here. Frame ID is at byte number 3 in this object data. 0, 1, 2, 3. See how that works? So back to this code. Y points to this table, this data structure. And we're going to load A with character move flag, which is, do I have that one in here? This is outdated, like I said. Character move flag equals 5. So an offset of 5 into Y. 0, 1, 2, 3, 4, 5 right here, which is the direction for the main player, but it's the character move flag for the beholder. Looks at that, loads that value into A. Long branch if equals 0. So if you don't do a compare, BEQ is 0, which is branch if equals. BNE, which is branch not equals, would be any number above or below 0. And so it saves you a compare. So I load A with that flag. If it's not set, so if it's equal to 0, I'm just going to go to behold path exit, which takes me out of this routine and goes on to the next one. But if it does not equal 0, so it's been set to 1, I'm going to go through and follow the rest of these procedures. So the first thing that we have to do is we have to look at what are the possible moves. At least this is how I did this. There could be a way better way than this, and I'm definitely open for suggestions. I don't particularly want to do a rewrite on it, but I've done it about 7 times anyway. So we load register U with tile board, which is basically it's pointing to a tile table. As I mentioned before, the table of all of these yellow bricks, the key, the green gem, this lock right here, this keyhole, I guess is the word I was looking for a while ago. It's a table that represents this 10 by 10 grid, but it's linear in memory. It's not like you see it here. So we point to the beginning of that table by loading U with that. And we load X to an object board, which is an object table. So that table contains the address of these data structures, right? So the starting address, see here at the end of Gem 5, I have an FDB of C093. Well, that's where the beholder starts. It keeps track of where the next object is. So X is going to point to the object table. So that's a table that's also 10 by 10 of 16-bit address locations for every gem, the main player, the beholder. And how this is used is like when my player goes up in this instance, he knows exactly what gem to move. So that's how that is used. And right in this instance, we're going to point X to the beginning of that table. Now we do load D with GBPOS. So GBPOS is a spot where it stores your index into the tile table. And then the very following byte after GBPOS is your index into the object table. So I'm loading both of those values in one shot, as opposed to load A, my tile table index, and load B with my object table index. I just load D with both of them. The tile table index goes into A, and the object table index goes into B. Now this next instruction, load effective address U, LEAU, is going to take U. We're going to add the contents of register A to that, and we're going to store it back in this last register, and in this case it's U. So I'm taking the tile table pointer, I'm adding the index into the table to it, and making that the new location, the new pointer location for that table. Now ABX does the same thing, because I ran into an issue where I would do an LEA X, A comma X, and I forgot that this right here is signed. So 8-bit values that go into there are signed, meaning that 128 and over is negative. So it was moving negatively into the table as opposed to positively into the table. Because I had, since it's a 16-bit table, I had some things that were over 128. For example, the beholder's object table index starting is 142. That's clearly over 128. So the old way it was going negative, so above the table instead of into the table. And I fixed that by using ABX. So B, as I stated before, was loaded with that table index for the objects. So in this case, 142. And ABX unsigned adds that to X. So it added 142 to X, which pointed at the beginning of the object table. So now we're 142 bytes into that table. That's where X and U are. Now I clear B, and I'm going to use that as a variable. So I've set it to 0 by doing clear B. Whew, okay, now so the first thing that I do, you could do any left, right, up, down. In this case, it doesn't really matter how you do it, but I just started with left because I thought it was easy. So I'm checking the cell to my left on both the tile and the object table to see if there's something there. So the tiles that are solid are stored to the tile table as 128 or above for their tile ID. So that way, if it's 128 or over, it's a negative number. So I can use a branch if minus or a branch if BP or a branch if positive. So branch if minus is BMI, branch if positive is BPL. Now how that works is I load this value. So I'm loading A with -1 U. So U is pointing to our tile table indexed at the beholder. -1 from that would be whatever cells to the left. So let's take a look at that here visually. So here's our beholder. U's pointing to him on the tile table. And now it's going to look at this spot right to the left just below this pink gem right here. My cursor's coming up black for you guys, but white for me. I don't know why. But just right there to the left, it's looking. Now, if it's going to branch if that's a negative number. So if there's a tile there, I just want to go check right because I know I can't move left. If there's no tile there, I'm going to check for an object. The object table has 16-bit values in it. So to grab the ID to my left that I don't want to be a 0, I'm going to go 2 spaces into that table, or 2 bytes over in that table, and I'm going to grab that. Now, if that's branch if not equal to 0, so that meaning that there's an object there, I'm going to go check my right cell because I can't move because there's an object next to me. Now, if there wasn't an object and there wasn't a tile, I'm going to OR B by 1. So I'm going to set the first bit this bit 0 is only one that's going to be set in B, and that's what that does. OR B 1 sets that first bit to 0. Now we're going to go on and we're going to check right. So we load A with 1U, which is going to be this yellow brick right here. And I'm going to branch if it's negative to go check above me because I can't move in that direction. So in this case, I would be skipping to checking above me because I can't move here. But let's say it failed and it was a positive number. It would now go 2 bytes into the object table. And if that was not equal to 0, it would go check up because there's a solid object there too. If there wasn't anything there, it would now OR B with 2. So the first bit would then be set. And now that happens for checking up and checking down. It's the same process. Checking up is -10U because I have a 10 by 10 grid. So to be above something would be -10. To be below something would be +10. And then for the object table, it's -20 and +20 because they're 16-bit values. So it's double that. Now, if those fall through and you can move up or down, it bits B to do the second bit and the third bit, or I'm sorry, ORs B to set the second or the third bit to be on. Second bit would be for up, the third bit would be for down. So if you could move in all of the directions, so if I can move left, bit 1 gets set. If I can move right, bit 0 gets set if I can move left. If I can move right, bit 1 gets set. There we go. So if I can move up, that bit also gets set, the second bit. And if I can move right, if I can move down, the third bit gets set. So a total of 15. So after all that's done, it goes down to this thing called check moves. So I compare the value in B to 0. It would be 0 if I found no possible moves. And if I didn't find any possible moves, so long branch if equals 0, I'm going to exit because I can't move anywhere. Otherwise, I'm going to just store B in a variable in memory called possible moves. And I'm going to use that here later. So now that I know that I can move somewhere, I'm going to bother with restoring the background. So that jumps to a routine, jump to subroutine, back restore, and then once that's done, it'll return right to here and execute this instruction right here. So this next thing is checking to see if the beholder's tile index and the player's tile index are the same. If they are, he'll go kill the player. Now, I'm not exactly sure if I even need this check right now, but I'll figure that out later. But what it's doing is load U, behold main C +1. That's one thing I intend to change. It's got behold main C has an instruction in front of it, and it doesn't need to. It can just be a variable in memory. So basically, what I'm doing here is I'm pointing you to the character's object structure right here. And now I'm going to load A with the tile index of the main player. And then I'm going to compare that to the tile index of the beholder, because remember, Y is pointing to the beholder's data structure. And then if those are the same, right now I have it branching to exit this path, but later it will be branched to this kill the player routine. Okay? So if that's not the same, we're gonna keep going and we're gonna analyze where we need to move. So right here, load a screen pass plus 1 comma u loads the x value, the x-axis value of the player into A. Now we're going to subtract from A the x-axis value of the beholder. And we're going to store that in a self-modifying code at player below plus 1 and player above plus 1. And the reason for that is I could just do store a player left and right value. Well, when I got down to player below, I would just have to load that back out of that memory address. So I'm going to just store it where it below, so where it would load it exactly. So as I have that highlighted, player below, it's showing it right here, plus 1. So player below would be this load A instruction, and then plus 1 would be here. So I'm setting that value to where it's just going to load it into A again. And then also for player above, which is down here, plus 1. Okay, so it takes the left and right calculation and it puts it in those two routines. Now we're going to see which one of those two routines we want to go to. So I'm going to load A, register A with the screen pass comma U, so it's taking the y-axis value of the player now, and it's subtracting the y-axis value of the beholder. And it's going to store that value in player up and down value. It's the spot in memory that I chose for that variable. Now, if it's a negative number, the player is above us. If it's a positive number, the player is below. So if it's a negative number, we're going to branch down to here, player above. So it's above us. I'm going to determine if I want to move up, left, or right. It's the same process as I'm about to go over for if the player is below us. So then we just, if it was a positive number, it wouldn't even go down here. It would just go right straight to here. Player below. So we're going to load A with whatever value we stored right here. We're going to, that's our left and right value. We're going to branch, if it's negative, to player is below and left. So if our left and right calculation, I'm taking the player and I'm subtracting the beholder. If it's negative, then the player's to the left of the beholder. If it's positive, then the player's to the right. So if it was negative, we would jump down here to player below left. But let's say it was positive. These two routines work the same, but they have different numbers. We're going to say that the player is below and to our right. So let's see if I can make that happen. I can't. Hold on. Player below and right. That's what we want. All right, so we're here. I am below and to the right. So that's putting him into this section right here if I move. So I'm going to load that possible moves value back into B, and I'm going to AND it by A. Well, what am I doing there? Let's say that our possible moves value was left, right, up, or down. So left, right, up, down. I should do it like this. Right or left, right, up, down. I know that the player is below and to my right, so I only want to look at moving down or moving right. So as you can see right here, I got my down bit and I got my right bit. but my up bit and my left bit are 0. So even if I could move in any direction, I'm only going to focus. Sorry, I put an or there instead of an and. I'm only going to focus on the ones that I'm concerned about, which is, let's switch back over here, down and right. So that's what this did right here, was it changed that value to that. Now, if it came back with, let's just say, for example, that it was actually just set that I could only go right. Okay, so I can't move down. If I AND this by A, it's still only going to equal right. I can still only move right. I'm just going to mask off things that are on that I don't want. I'm going to shut those off. So that's what happened here. Now I'm going to compare B to A. And the reason that I do that is I want to see if I can move right and down. So those are both possibilities. And if it's equal to that, then I want to branch to this player below right 0, which is going to process it. If the player is below and to the right, which one of those distances is farther away? I'm going to move that distance. If for some reason both bits aren't set and I can only move down, I'm going to try and see, compare B to 8, because that would be equal to only my down being set. See that? My down set. So if I can only move down, I'm going to just jump over and move down. So long branch of equals 8 to behold move down. If that isn't true, then I'm going to compare 2 to see if I can move to the right. See? That bit is set. And if I can move right, I'm just going to go move right. So long branch if move right. So I put this safety net in here. I don't even know if I need it. But if any of these 3 conditions fail, I'm going to just exit right out of the thing. Because if I didn't have that here and they failed, it would just be like you could move right and down. So, but I didn't want that. And honestly, I don't know if I need it, but I'll find that out later. For right now, I just put it in as a safety net. So if we can move right and down, right here, we're going to load B with the player up and down value. So the distance up or down, in this case, it's going to be the distance down. I'm going to store that in some self-modifying code right here. Player below right 1 plus 1. So right here. So I'm going to compare A, which contains our distance right that the player is. I'm going to compare that to our distance down that we just grabbed. So when I do store B player below right 1 plus 1, that's right here. I'm going to compare my right distance to my down distance. If my right distance is higher or the same, I'm just going to jump and move right. If not, it's going to fail and it's going to go down here and I'm going to jump to move down. And the left works the same way. We mask off the bits we don't want. We focus on the ones we do, down or left. Then we check if we can move left or down, and we go and we make a choice based on distance, whichever one's higher. If I can only move down, I'll move down. If I can only move left, I'll move left. And that's how it works. And then the same for if the player was above. It would do the same calculations. See if it was left or right. If it's left or right, it goes, if it's left, I'm going to be like, the player's above and left. We'll make our decisions. If it's right, it would go to the above and the right thing and do that calculation and see if it needs to move a player. Same exact thing, just different, a few different numbers, basically. Okay, so once we had determined which way we were going to move, we would jump into a movement routine. So let's just say behold move left. I'll go over this one once because it's the same things that need to be updated for moving right, up, and down. Just some of the numbers are different. So we first start by pointing X to the object table. We load B with our table index for our current table index for the beholder, and we add that to the table to offset it to where the beholder currently is. I'm going to load u as 0, 0, 0, 0, and I'm going to store that back into the table. So store u comma x puts it right where the beholder used to be. Now the object table was storing his object instance ID, which was basically the address, right, of his data structure. So we've now cleared that out of that space because he doesn't exist there anymore. And now we're going to add 2 to B. So we're moving, or I'm sorry, we're going to sub 2 from B because we're moving that to the left. And we're going to restore B as the new index into the object table. Now we're going to LEAX minus 2 comma x. So we're taking 2 away from the x pointer, which is pointing to the table. So we're going to move to the left, and we're going to store y at that spot. And y was the pointing to the address of the data structure of the beholder. So now his instance ID, which is his address of his data structure, is now stored on the object table. So anything that's going to try and collide is going to detect that he's there. So now we're going to load A with the index to the tile table, decrement it by 1. That's what dec A does, is it takes whatever's in A. So in this case, it would be 71, and it's going to make that one number lower, so 70. And now we're going to store A back, the new tile table index. Now we need to move him on the screen, and that's what this does. So load A screen pass plus 1, which is the x value, x-axis value only. We don't want to mess with y, so we just want to grab that byte that represents the x value. We're going to sub from there 4 bytes because I have an 8 by 8 pixel sprite. And in this mode, the 16 color mode, each byte equals 2 pixels. So I'd only have to subtract 4 bytes to move 8 pixels. And then I store that back at screen pass plus 1. So that's our new x value. And now it just jumps over to the next function that needs to take place before it cycles back through and displays everything where it needs to be. And that's basically how it works. As I stated before, I need to tweak it to detect if the character is there, or the player, as opposed to it detecting the player as an obstruction. It needs to target him as a thing that he can move to and go kill him. And then I'm going to see what that change yields. It might fix some of the other movement issues that I ran into. But I think that there's going to have to be some determination with the left and the right stuff that it's figuring out right now. I don't really know how to explain it in words right now. I kind of visualize it in my head, but I sort of kind of know what to do. So I hope that you guys enjoyed this video and maybe learned some stuff. Like I said before, I appreciate any kind of feedback. I was doing this off the cuff. I think trying to script it and have a structure would probably be a good thing, but it'd be really time consuming. Maybe I can just do an outline of what I want to cover, because when I'm presenting without any kind of script or outline, I tend to stumble over my words, and maybe it's harder for you who's watching it to understand what I'm saying. So yeah, please provide any kind of feedback that you want. Try to keep it, don't be a dick. And be constructive without criticizing me. I know that maybe in comparison to some people in the Coco community, my coding might be junk. There could be way easier ways to do this. I actually appreciate the feedback of an easier way, but don't trash me because my code's not as efficient or as cool or whatever as yours is. That's all I'm asking. Because I try not to do that to anybody else, but human nature sometimes, right? All right. Thanks again for watching, and we'll catch you guys next time.